Assembly order planning for modular structures by autonomous multi-robot systems. The NASA Armadas project consists of robots that can build structures out of building blocks called voxels. While building, the robots can walk over the structure of voxels. They can pick them up, place them down, and transport them over longer distances. By working together, the robots can create large structures. To enable precise alignment of the voxels, each of them has some bumps and corresponding dents. Because these dents extend slightly outside of the bounding box of the voxel, voxels cannot be placed in between two already existing voxels. This is called the node-tied building constraint. This requirement poses a constraint on the construction order of the voxels. For example, when building a structure like this, a naive approach would build the voxels from the ground up. However, doing this without care leads to a violation of the node-tied building constraint. The question that we try to answer is how to automatically compute a valid build order. Moreover, to optimize the construction time, we want to ensure that robots can work on different parts of the structure at the same time. This increases the amount of parallelism and should lead to a shorter build time. Therefore, we not only want to automatically compute a valid build order, but one that maximizes the potential parallelism. Our algorithm works as follows. First, we create a so-called slice graph from the configuration, where each node corresponds to a connected layer of the structure. Then, we ensure that all nodes in this graph are reachable from the lowest node by inverting some of the edges. Next, we simplify the graph. We do so by looking at any edge in the graph that is the only outgoing edge for one node and the only incoming edge for another. If such an edge exists, we combine the two nodes into one. We keep doing this until no such edges remain. We now have a graph where each node represents a subset of the voxels in our configuration, and we have a clear dependency on each of the subconfigurations. For example, all the blue and the orange voxels need to be built before the robots are allowed to start on the pink voxels. Moreover, the blue and orange parts can be built independently from each other. We can prove that our approach does not violate the node-tied building constraint, and it creates build orders that are faster to construct than naive orders. This simulation shows the assembly done by the Armada system. Thank you for watching.